So yeah, welcome to the CSP Primer, Content Security Policy Primer. Really excited to have you guys here today. We're actually, you're getting a bonus talk here. There's going to be actually not one, not two, not three, but four of us talking in one talk. So, this is a real big deal, guys. Come on. Anyway, so my name is Joel Weinberger. I'm a Chrome security engineer. I'm going to sort of give the introduction here, a little introduction to content security policy, and I worked on this with Caleb Kern, excuse me, and Ken Lee right over here. So let's get started. Quick show of hands, just out of curiosity, how many people are familiar already with content security policy? Awesome, awesome. Here's the harder question. How many of you have implemented content security policy on a website? Oh, actually pretty good, not bad. All right, so, right, even better question, does it work? Fair enough, good point. So hopefully by the end of the day, I will have you all convinced that if you run a website, you need to be implementing content security policy on that website. So let's see if we can get started here. What is content security policy? Well, there's something very interesting going on with this guy, right? He's a nice, strong, good-looking guy here, but he's doing something that I absolutely love. I love this guy. He's doing something so smart, at least from the security community, right? He's belt and suspenders, right? This guy has such a good baseline of security going on, and it's just so vitally important, right? And all of you software engineers and developers out there, you know how to deal with security problems, but you also know you need some good baseline, some sort of way that in case things go terribly wrong, there's still a bottom that you can have some security at. We're all about cascading failures. Those are often the key, and it's really important to have defense in depth. And it turns out that for a lot of web application security problems like cross-site scripting, there isn't necessarily that system in place. And that's where content security policy comes in. So a little more seriously, let's see if we can get a sense of what content security policy is in sort of one line. And it's basically a header, an HTTP header, that specifies a static declarative policy for your website that effectively sort of says what the allowed content on your website is going to be. That's a very rough definition, but sort of gives you an idea about what's going on here. So this right here is a simple example. This is a real HTTP header that you can go and put on your page today. And let me tell you, this is the most beautiful thing that you will see at this entire conference. And at least I hope to convince you it is by the end of this talk. And let's sort of go see what's going on here, see what this is all about, right? So the first thing that's going on is this content security policy is defining for the website that this header is going out for the allowed set of script sources that this page is allowed to execute JavaScript from, right? And in this case, it's got two sources. It's allowed to load it from the same origin that this page is. So if you're at foobar.com, it'll allow scripts to be loaded from foobar.com. In this particular case, we're also going to allow apis.google.com. So the point here is, you can define specific sources that you'd like to load your page from. So what does this actually mean in practice? Let's say you have some sort of template, favorite web programming language, PHP, whatever, and you have this basic template of HTML and some paragraphs, and then there's this empty space you're going to put some user defined input into. Perhaps it's a web forum, you're expecting to see things like this, Joel was here, or whatever, some pretty benign content. But as you're probably all familiar with cross-site scripting, we're always worried about the really bad scenario, right? Some malicious guy coming along, and inserting this script tag, right? And it's going to load his evil script from evil.com, and he's going to load this on the web pages of all the visitors to your site. And oh, this is just so terrible, right? Well, here's the beauty of content security policy. You may not have known that this content was possible. You may have missed the sanitization that would have prevented it, whatever. Content security policy says, well, this script that you're loading isn't coming from either of these sources, so it's going to block it. Just right off the bat, right? No more cross-site scripting here. The script will just not run. The browser enforces this. It's beautiful. It's just so simple and beautiful. So let's go into a little more details about what's going on. So a little more details about what content security policy is, right? It helps you to enforce, like I said before, static policies about the content of your pages. It helps you to stop cross-site scripting and sort of more generally all sorts of different kinds of content injection on your pages. Basically, you do this by providing a white list of allowable sources, right? In the web today, you have to sort of go around and explicitly say, this is where I expect user input, and I don't trust this input, so we should sanitize it and take out all the bad things, so yada, yada, yada. content security policy sort of gives you a baseline and says, well, forget all that. I know a certain set of sources where I'd like to allow these scripts to come from, and if you see a script from somewhere else, get rid of it. Don't allow it to run. So we already talked a little. Well, let's talk about how it's actually going to stop cross-site scripting here, right? So, like we said, it's a whitelist of script sources. This is basically the same thing we saw earlier. And what happens is if you're loading this page, evil.js, like we saw before, it doesn't let you do that because it's not one of the known sources, right? But there's a couple other tricks here as well. We've got to do a couple other things. So more specifically, what happens if you get this as your, if this is your input? So notice that this script is not getting its source from anywhere else. It's doing it right there inline. And, instead of being Joel was here like earlier, it's just going to do some bad stuff, right? Well, obviously this is terrible. So in fact, we're going to stop it. And we're going to have to, with content security policy, if you want to stop cross-site scripting effectively, you're going to have to ban inline scripts, right? Well, unfortunately, this of course does have the side effect that means your legitimate code also won't be able to run because that's an inline script as well. So that's one caveat right here, although there's a further caveat that we'll mention later as well into how you actually can run inline scripts. And then furthermore, of course, every security expert's favorite function, eval, in JavaScript, where if you're expecting some untrusted user input into the middle of it, of course, if that input is do evil and call some bad function, that can do really bad stuff. So we're going to have to take eval, and we're going to ban that as well. So that's the three ways we're going to be stopping cross-site scripting with content security policy. We're going to specify a white list of allowed sources. We're going to not allow inline scripts, and we're not going to allow eval, right? So let's talk a little bit about where sort of content security policy fits on this little arbitrary graph I drew here. There's all sorts of different kinds of security tools out there in the browser, and I just want to sort of, give a sense of where content security policy compares to them. So of course we have things like X-Frame Origins, which is a really great header that you can run, sort of really simple, gives you some basic power to stop clickjacking and things like that, and stop your page from appearing underneath other pages, and that's great, super easy to use, but sort of limited in its powers. We've got things like HSTS, which helps to stop, these really powerful man-in-the-middle attackers who are sort of taking over, who are getting between you and the actual server you're trying to reach. And that's great. It's awesome. It's not that tough. You just need to get a certificate. And in the case of HTTPS, if you want pinning, you've got to get that into a browser, which turns out is not so hard. But it's still a very specific kind of attack that's going to require a very powerful kind of attack. So, in some sense, it's not the most powerful thing you can do. And CSP is aiming to be sort of the Incredible Hulk here, right, to use Caleb's term. It's trying to be the big, beefy guy, which is definitely going to require a little extra difficulty. You're going to have to maybe refactor your code a little bit, which the other two don't really require. But it's going to give you this power against cross-site scripting, which is sort of the big beast and the big enemy of all of us. And it really gives you some awesome power in defending against that and content injection attacks in general. So that's sort of where content security policy is trying to fit here. So let's go over this quickly, just why you want it, why you need it today, not tomorrow, not a week from now, not a month from now. You want it today because it's going to stop cross-site scripting. Well, most cross-site scriptings. There's some, obviously there are some caveats everywhere, but and you're going to be able to enforce that the content you intended is going to appear in your web page. And this is a really cool part, you're going to get deep insight into the misbehavior of your application in the wild. So we'll talk about that in 1 second as well. So even if you're not worried about cross-site scripting, what about making sure the rest of, which you should be, by all means, if you're writing a non-trivial website, there's all sorts of other content on your website. So, there's style stuff, there's images, there's forms, right? And just to take a really sort of absolutely ridiculous example, if you're the NewYorkTimes.com, right? Even if you stop cross-site scripting, you'd really hate for somebody to inject an image on your page which says to go to joelsnews.com, right? This would be just horrible. The real trick here is that content security policy also lets you specify trusted whitelisted sources for your images and for your styles and things like that. So it gives you a lot of other power just beyond cross-site scripting as well. So we can sort of start moving towards a world in which we're protecting against that next generation of attacks that once we defeat cross-site scripting will probably come around. Press back, sorry about that. And this is one of my favorite features of content security policy. So, of course, content security policy, you might not want to turn on full blast content security policy immediately because maybe you're not ready to quite refactor all your code yet. You're not sure it's going to work. But don't worry, we have an answer for you too. Content security policy, we saw this policy approximately earlier, a little different. So say you're foobar.com. This has a really cool set of things. We're going to say that the default source, so that applies to all your sources, images, styles, scripts, etc., is going to be only the same origin. And we're also going to have this report URI bit, right? So what's going to happen is if bad guy injects a script, tries to source it from this attack.js, we're going to, of course, stop it because it's loading this not from foobar.com, but it's trying to load it from evil.com. But what's really cool is the browser is then going to report back to you this behavior. And it's going to report it back to the URI you specified, and it's going to give it to you in this beautiful JSON. Who doesn't love JSON? And it's going to tell you the directive that was violated. It's going to tell you what the original policy was. It's going to tell you the source, so on and so forth. How cool is this? I mean, this is really awesome. Even if you're not ready to turn it on today, you can understand if there's an attack going on. You can see attacks that are going on. You get deep insight in the wild about what's actually going on your website. So even if you're not ready to turn on full blast content security policy, you can still be the hero at work when you find out about that cross-site scripting attempt that occurred out in the wild. And this is just so powerful, and there's really no excuse not to just go out tomorrow and turn this on. But of course, there's tons more coming along. This is just tip of the iceberg. We're going to talk about some more of the features in just a second. But we're talking about stopping XSS, stopping frame busting is part of it. iframe sandboxes are part of content security policy. You can specify sandboxes. You can stop insecure frames. All those caveats about inline scripts. Turns out we have an answer for that too. There's script hashes and script nonces you can do. And there's more to come. We're still working on it. It's lots of stuff in all the browsers is coming up. We're trying to work on new standards for actually providing integrity of the resources on your web page, not to mention maybe more modular development with sub-origins, which would be a new feature as well. So we're really excited about content security policy. We really think you need to get started with it. We've got some resources that are really awesome. We've got some really cool resources to get you started with content security policy, help you to learn more about it. I'll put this up on my personal website, of course, so if you guys want to check it out later, by all means. But I really hope you all, if you're a developer, you go out tomorrow, you just get, at the very least, get the reporting going. But there's no excuse to not start stopping cross-site scripting today. And with that, I guess I'm turning it over to Ian. By the way, we'll be taking questions at the end for all of us, so if you just hold off for a little bit.
Thanks. Okay, cool. Hi, my name is Ian Melvin. I'm currently an application security engineer at New Relic. I work out of our engineering headquarters in beautiful Portland, Oregon. Before that, I worked at Mozilla. I worked on Firefox. I shipped a CSP implementation for Firefox that was compliant with the 1.0 spec. And during that time, I obviously spent a lot of time discussing CSP on the W3C list, and I still try to chime in both with Mozilla bugs and on the list when I can. So my presentation is about how to sell CSP to your boss, like a boss. So I'm going to start off, I'm going to give you three basically key talking points that you can use to convince your boss that implementing CSP on your site is something you should do. So 3 reasons CSP is awesome. Joel touched on this a lot just now, but obviously CSP is the most thorough way to stop XSS. We have modern web frameworks these days like Rails that escape output by default. We have sanitization techniques. We have libraries. AngularJS has an ng sanitize directive that's pretty cool, but we still have XSS on the web. So the beauty of CSP is it doesn't rely on every web developer having to know how to implement a secure filter. People don't have to mess around with whitelists or try to use a blacklist. CSP can basically stop most XSS attacks with a single HTTP header, like Joel said. There are bypasses to CSP. People do find them. I basically consider those browser bugs. They're bugs in browsers' implementations of CSP. They can be fixed by the browser vendor once. Every developer doesn't have to know about them, and they're just fixed at the source, and then there's no more XSS. So as new vectors of script execution are found by wily security researchers, they can basically be blocked by the browser and not the developer. Number 2 reason CSP is awesome. It's transparent to the user. So I don't mean this to say that the user doesn't know they're being protected, although they probably won't, but more that there's no action needed on their part. So CSP isn't something that a user needs to turn on. It's not something they need to opt into. It ships in Chrome, Firefox, and Safari following the 1.0 standard. We live in hope that IE will implement it someday. Chrome and Firefox have some 1.1 features as well that are behind prefs and flags right now. And the 1.1 spec, like Joel said, it's firming up. And I would expect default support for CSP 1.1 probably in the near term. So reason number 3, CSP is awesome. Since CSP is awesome, if you use it, you look awesome too. So using CSP, it shows you're on the cutting edge when it comes to web security. It shows you're proactive. It shows you're taking active measures to protect your users. And okay, so you've given these 3 reasons to your boss. Your boss is convinced. Says, okay, CSP. This thing sounds pretty good in theory. But for most of us, we're looking at adding CSP to our organization's web applications. They've probably been around for a while. They have a lot of functionality. There's over 9,000 pages. There's probably lots of important third-party content loaded from all over. And like Joel was talking about, there's probably inline JavaScript as well. So your boss is going to say to you, okay, this sounds good. I'm convinced we should do it. How are we going to roll out CSP? Well, the immediate answer should be obvious. We're going to roll it out like a boss. So rolling out CSP in the real world. Like Joel mentioned, you can use CSP reporting to learn about what's going on your website. You can start with the CSP report only header. It's not enforced. It will only send violation reports, so there's no risk of breakage. You can use the report only header to get your kind of header deployment strategy rolled out, to figure out how you're going to handle CSP violations and handle reporting, and basically debug. Like most things, I think in security, I think the best thing is just to get something going and then incrementally improve and iterate on it and make it better. You can gradually tighten the policies. But getting something deployed and getting CSP out, even in report-only mode, it stops things from getting worse. And it's okay to start out using unsafe inline. Like, okay, you won't get all of the XSS protection that CSP can give you, but you will protect against loading malicious contents from other sites. You will protect against eval. It's just better to start and build on it and get something out there. And the other part of rolling out incrementally is it can be very difficult to roll out CSP across your entire site on every page. So maybe just pick one page and get CSP there and kind of get started and then spread it out to more of the app. So potential difficulties. Inline scripts. It's very hard to get rid of. I have talked to many people about deploying CSP. And in my experience as well, and anecdotally, the biggest obstacle to getting it rolled out is inline scripts. It's a big pain to move everything external if you have a lot of inline scripts. And there's a performance hit as well, which a lot of people complain about when we tell them they have to get rid of inline scripts. So the answer here, I think, long-term is non-source and hash source, which basically let you selectively whitelist inline scripts by either a nonce or the hash of the script. And you can do that. You can still have inline scripting. You can only have the selectively whitelisted scripts able to run, and you can then remove unsafe inline. So there are implementations in Chrome and Firefox. Shout out to Garrett and Joel for implementing those. But they're not usable yet. And they're also behind pref. They're also behind prefs and flags in Chrome and Firefox right now. Yeah. Yeah, you can use them with the prefs. Because the 1.1 spec is not done yet. It's still going through the W3C process. It's making good progress, though. But you can flip those flags and prefs. You can try these out on your site. You can kind of understand how it's going to work when the spec is finalized and those are enabled by default, and get ahead of the game. And another cool thing here is tools can automatically generate hashes and nonces for your app with very little development effort. Neil wrote a gem as a proof of concept that basically calculates hashes for scripts that are served in Rails and would do the hashing for you. So you might be able to get this whitelisting by just flipping a switch in your framework. So that's the other important thing to remember about rolling out CSP is you're not alone. Other people are trying to do this. Other people are building tools that exist to help serve CSP policies for various frameworks and languages. They're writing tools to help generate CSP policies for the application automatically, so you don't have to figure out every single place that your app loads content from. And people are writing tools to parse CSP violation reports and basically process those programmatically. And I'm very hopeful that there will be more tools and more automation and more assistance in getting these policies out as CSP continues to gain traction. So continuing along those lines, read this thread. Garrett Robinson started it. It's awesome. It's titled CSP Transition Tools. It's on the W3C web AppSec list. There's a link to it here. And Garrett basically started this thread for people to share information about tools that they've built to help deploy CSP, or strategies that they've taken, or basically processes that they've come up with. People to share their stories and presentations about rolling CSP out on their site. If you have tools or experience trying to roll out CSP, it seems like not that many people have tried to deploy it yet. probably because some of the problems that I talked about. But if you try it and you hit roadblocks or you create tools to build it, please post in this thread, and it can basically be this repository of information and shared experiences. Because I believe very strongly the more that we roll out CSP, the better we'll all become at rolling out CSP. We can basically share our knowledge. So extra non-boss bonus. This is probably more for AppSec folks than bosses. Joel touched on this. CSP reporting helps you learn all sorts of things about your site. It lets you understand the experience that users are having in their browsers interacting with your application. You can find out what content might be injected by their browser add-ons or proxies that they're going through, or even malware. CSP can help you detect mixed content on your pages. If you have a content security policy that only allows content from HTTPS, you can get violation reports when you have mixed content. You can find out about it before it breaks in a browser and your users are affected by it. So in general, CSP reporting is another really great data point of what your users are really experiencing on your site. And in conclusion, remember, CSP is awesome. And I want to give a big thank you to everyone who's been advocating for CSP and working on it for a long time, and especially to Neil Matodal and Scott Behrens for their feedback and great amount of help putting together this short talk. Thank you very much. And now I will turn it over to Scott.
Test. Cool. Awesome. Well, thank you guys for sticking around. We're super excited to be talking about CSP. Patrick and I have been talking about it for quite a while, and we're great to see people actually rolling it out, interested in implementing it. The more of you we can get on board, the better CSP is going to get. And actually, we're going to touch a little bit on that during our presentation today. What Patrick and I are going to be focusing on is the web and CSP in 5 years. So kind of doing a little bit of a forward thinking, a little bit more of an abstract talk, just thinking about how CSP is really going to fit into the World Wide Web in 5 years, and what maybe some of the challenges are if you're not implementing it or if you actually are. So just a brief background, I work as a senior application security engineer at Netflix, and Patrick works breaking apps at NeoHapsis in Chicago. So really what CSP is it's a shift in thinking. And what we're doing is we're moving from a blacklist approach to a whitelist approach. And as security engineers, we know how much we love whitelists, right? Whenever possible, we try to whitelist things. And the reason that we do this is because we run into these circumstances where developers just don't get things right. We've talked a little bit about how web application frameworks have automatic encoding and escaping, and they provide you some functionality, Rails, frameworks like that, but you run into these edge cases sometimes, right, where things just don't quite line up right. And potentially maybe you inadvertently introduce cross-site scripting into your application. And we're not expecting developers to get stuff right all the time, and when that kind of happens, we can look back a little bit and think about the 90s, right? Like, you remember firewalls? Like, firewalls really was kind of a different shift in thinking, right? With firewall technologies, we decided, hey, let's start whitelisting what kind of resources should be able to access our network, information services, ports, etc. And that awesome Will Smith photo. So, and then we had the 2000s, right? Napster, Kazaa, awesome, right? But really, there was kind of another shift in thinking, right? Let's think about exactly what our database should be doing when it runs queries. So we started to come up with things like stored procedures, prepared statements, DEP. These are things that are predictable, right? And we can kind of see that there's a little bit of a parallel here between what we now see as common best practices. We're always recommending you should be using stored procedures on your SQL statements. And we're seeing that the approach that we use to solve problems like SQL injection in the 2000s and issues like network-based attack in the 90s, we're basically kind of using these whitelist style approaches. And we can see how CSP really fits directly in with that model. And it's one of the reasons why we should be rolling it out now. And really what's the point here is CSP makes software more predictable and makes mistakes less exploitable. And I think that that's kind of one of the take-home messages that I want to leave with you all today, is if we can make things more predictable and we have a clear understanding of what they're going to do, It'll be easier for us to detect when things aren't working correctly, and it'll make the mistakes that we do make less impactful for our application.
So therefore, this slide shouldn't be a surprise, is that is kind of the underlying idea of CSP, is that if you are using, as I think it was Joel was talking about, if you're using that subset of JavaScript that is well understood, that doesn't have the evals in it, that doesn't have the kinds of pieces that make maliciousness easy, then we can enforce that, and the entire application becomes much more predictable. It does exactly what you as the application developer wanted it to do in the first place, and nothing more. And you're transitioning information from you, the developer who had good information about what the application should do, to the browser that has the ability to enforce it. That's really the power here. And then the end result is that Scott was talking about, and going back to what Michael Coates said yesterday of, it has become unreasonable to expect developers to get every single encoding, every single input validation, every single output escape perfectly right. So we can step back from saying bad developer, which is just not productive, and say, okay, the belt and suspenders approach of defense in depth allows us to have a better relationship and to, as security people, provide something productive. So right now it's about browser security. It's about content security policy. It's about web application security. And we're seeing many browser headers tackling really important things in browser security that allow us to be proactive. There's a bunch of other headers out there, and we're beginning to see stuff getting pulled into content security policy as a place to have, a centralized place to have lots of these security directives.
If I could just kind of comment too, one of the things that's really interesting is we're in a time where actually, often in security we're like, oh, we're losing the race, we're getting beat, by the bad guys. Like, from an application security perspective, we're in a pretty good place. We're coming up with some decent defenses that really kind of give us an edge. I mean, yeah, there's a little bit of overhead to potentially roll out content security policy, but we're talking about severely crippling common application vulnerabilities that have been plaguing this industry for forever. So we really have an opportunity in the next 5 years or so to completely change the threat landscape for application security.
All right, so right now, the way we're talking about it's still a fairly new technology. It's not being used on lots of sites. We would like it to be used on lots of sites, but it's not there yet. So what needs to happen over the next few years, what is going to happen over the next few years? Improvements in reporting. You get useful information from these reports right now. There's just fantastic stuff in there about getting real-time data about potential attacks on your users so that you can turn around and fix the app or protect other users, even those who don't have CSP. That reporting is going to continue to get better. Tools to slice and dice and roll up those reports, those are going to be written. So if you're looking for an interesting project, if you want to dive into that, all of that kind of stuff needs to be written right now. More sites adopting CSP, this idea of, it would be insane to not use prepared statements or stored procedures right now. Like if you're doing SQL without that, you're doing it wrong. That's where CSP will be in several years as the expected standard way to eliminate cross-site scripting. And if you're not doing that, the question should be, why are you not doing that? Title of the talk. There's plenty of information out there right now. There's going to be more, and there will be more case studies as more people are successful with this. There's some out there now. There's a bunch of websites. Talk to any of us. We can tell you the stuff that was useful to us. Middleware frameworks. There's, I think, Neil has built it into Rails. So there's a Rails gem for it. The equivalent probably still needs to be created. Has anyone done Django yet? Oh yeah, all the major frameworks. Okay, so they are there for all the major frameworks. So if you want to use this, the support is there. And then possibly in the future, we'll get to the point where a framework will help you come up with a policy that will work, 90–95% for your website so that you don't have to start from scratch. All right. Problems in 5 years, I think someone touched on this. There will be edge cases, there will be bypasses, there will be all those things, but this gets back to some of the conversation from yesterday of it raises the bar for attackers significantly. Now, instead of just being an easy to find reflected cross-site scripting, now they can do the injection, but now the stars have to align for the exploit to actually work. They have to be using a browser that doesn't support CSP, or they have to be hosting a script on some other subdomain that you forgot about that's included in your whitelist, any of that kind of stuff. Now the effort for exploitation is significantly higher. All right. So we've talked about this just in the sense of regular web applications that are out there, internet accessible, normal web apps. But JavaScript is being used in tons of other places, in lots of other situations, like if we've got the HTML5, it's going to have extraordinary power over what your desktop can do. Some of these things are getting to the point of, transparent file system access or access to render out to your video card. Those kinds of things can do much more interesting, much more substantial attacks against your entire system, not just your browser, not just the web application. So having this framework in place to be able to be proactively secure against increasingly more potent attacks is huge. Mobile devices, we've also seen, I've assessed mobile applications that were largely HTML and JavaScript that had the JavaScript was being called by native functions, and the results of that were being used to write to the file system and to access device functionality of the device. So all of a sudden you need a content security policy for a smartphone app. Those sorts of things, those are all coming down the road, and content security policy is finally, as Scott was saying, letting us get ahead of that.
And that's pretty much it. Thank you guys.